Okay, now we are going to answer question number 4, which is about momentum. Directly we go to the question part A. State and explain whether the collision is elastic or inelastic. So as we know that the speed is changing. The initial speed is 5.2 and the final speed is 3.6. So when the speed is changing, we know that the kinetic energy is also changing. So the kinetic energy from the first is not equal to the kinetic energy after the collision. So this is inelastic. So inelastic because because the kinetic energy before the collision before the collision so before the collision is not equal to the kinetic energy after collision. And for part B, calculate the change in momentum of the ball during the collision with the ground. So the change in momentum is delta P is equal to mass times V2 minus V1, which is the changing of velocity. We know that the mass here is 0.25, the only mass, 0.25 times the V2, which is 3.6, if going upward is positive and going downward is negative. So positive 3.6 minus negative 5.2, which is equal to 3.25 times 8.8, which is equal to 2.2 kilograms meter second minus 2 meter second minus 1, meter second minus 1. Okay, so the next one is determine the average force on the ball during the collision with the ground. So the force is the change in momentum divided by the delta T, which is 2.2 divided by, now that the time taken is 0.18 or 0.18, which is equal to 12 Newton. So the answer is 12 Newton, is 2.2. And the last one is the ratio H2 minus H divided by H1. We know that the kinetic energy, the potential energy is converted into the kinetic energy. So the one that has the height is the potential energy. So we can divide it, the kinetic energy, which is the Ka2 minus Ka1 is equal to mgh2 per mgh1, which is equal to, can be cancel out, h2 minus h1 is equal to this one, half mv2 square divided by half mv1 square. Cancel out this. So v2 is equal to the one that 3.6 and v1 is 5.2. So 3.6 square divided by 5.2 square, which is equal to 0.48. So this is the result, the ratio of H2 divided by H1. Okay, for the next question, we will continue for the next question in the next meeting. Thank you.